the big presentation downstairs had this crazy like radio headset. Those are horrible. Right. Should we wait for her to come back, or should I start? Or all right. So thanks for coming. Should I still tell your name, or you heard it many times, right? So I gave this title Introduction to Object Stores. So it's meant to be, so the focus groups are meant to be like a more deep dive sessions, but object store as a whole is rather different from general storage from SAN and NAS. So it's somewhat technical, so I'm not gonna like, you know, sell you cloud and stuff like that. I will technically discuss what it is, but it's definitely a little higher level. So if you compare what we did yesterday with VMware kind of stuff, it will be definitely a little bit higher level. So this is the little bit more politically correct version what I said yesterday, the flash and trash. But this is basically this two-tier model is the future of the data center, storing data in the data center. So everything which is applications and core data is going to store on flash, and even more on flash devices, and everything else which is like cache-based workload, a lot of data which you need to store. You have to store either because you are regulated by an internal rule, or you are regulated by a government, so you cannot delete those. You need to store it somewhere. And basically, it seems that object store is the de facto standard now for storing core data. And the reason is very easy, because Amazon a couple of years ago figured out S3, the simple storage services, to provide a cheap way to companies to store core data. And basically the idea is fantastic. So S3 as a protocol is extremely simple, especially for developers. And it's pretty affordable, but there are a lot of reasons, mostly political and data regulation reasons, that you just cannot store everything in the public cloud. So that's why most of the storage vendors are, showing up with object storage-based services, because you still need to figure out how to do exactly the same thing in your own data center, what Amazon is doing in the cloud. So object store is meant to be a large data set. So it can be anything, which generates a huge amount of data, either mobile or architectures which generate a lot of research output, and anything you can imagine which is not structured. So think like anything what you will store today on a NAS, but basically too big or mostly used by applications, so it's just too much to store on NAS. Data which is never deleted, so that's the very important aspect of the object stores. We will touch this part. There are basically 3 use cases today, which are very, very typical to object store. One of them is archives, and that's going forward. Object stores are going to be the next generation of tape or the next generation of cloud, where you throw in everything. Obviously, I can't say tape is dying, because we've been saying that for 15 years now, and that tape is still well alive, and everybody is using at least a little bit of tape. But going forward, it seems that object stores are complementing and mostly taking over the basically the reason that tape still exists. The other use case is media repositories. Think like anything customer accessible unstructured data, so anything from Dropbox to iCloud, media services like Spotify, YouTube, iTunes, they all use object store in the background, all of them. And the third one, honestly speaking, I don't really see it in Eastern Europe yet, but large service providers who provide web data services, they started to use object store instead of NAS. Most of the web services companies I work with, they use NAS for this. So typically they use On top, they have NFS services, and they have Linux front ends which are serving the web services, and that's how they work. But basically, the future of web repositories, especially the huge amount of data they generate, is again object store. So, what kind of stuff we have in an object store environment? So, clients, obviously, we have clients who are accessing the object store. They basically accessing object store through an API. So, the object interface itself is nothing else than a web interface. So, we are using basically standard HTTPS connections from the client to the server, and we speak an API. There is an object key and name, so that every single object has a name and has a unique identifier. And also, this is where the value of object source comes in. It comes with a rich metadata. So basically, you have a unique object, and you can describe the object with a massive amount of metadata. From a storage bit perspective, so I will speak a little bit mixed, generally speaking about object and some our object store implementation specific thing, and this is specific for us. So we have 3 levels. The lowest level is the object, so every single object needs to store in somewhere. We store the objects in buckets. So if you're coming from the NAS world, bucket is similar to a folder. So it's basically a bucket where you throw in every single object which basically belongs together. The next level is a tenant. So it's meant to be a cloud-based storage. So it's a basic requirement that the environment is multi-tenant and you can isolate the clients from each other. So you can create like virtual object stores on top of the physical. And we call grid the whole environment. Typically, a grid is a multi-site, multi-node environment which replicates data between the different sites. So I have a short comparison to NAS, SAN, and object to give you an idea of how objects look like and what you can use it for. So the main difference between NAS and object is that NAS has been originally built for file services, but through the years, the improvements in NAS allows us to run applications on it. So for example, if you think on that you can run an Oracle database on top of an NFS file system, or you can run a MySQL database on top of an SLB3, it's pretty reliable. So NAS is much more closer to SAN in terms of the application usage, what you can do with it. Object is completely different. Object was mainly built for our hypes and keep data on the long term. So it was more like built for write something once and then read it many, many times. So it doesn't really meant to be running like databases which generates a lot of updates on the same blocks, okay? One of the reasons that object stores are growing extremely fast is because new type of applications generate a lot of data. That's alone not the reason, because okay, I generate a lot of data, but I could store a lot of data on top of NAS or on top of SAN, so that's alone not really the reason. The reason is that the application developers need to figure out how they can store data, okay? So if I'm an application developer and I need to build an architecture where I store data on top of SAN, I need to handle low-level devices. So I need to handle, block devices, need to figure out how I can work with it, or I can work with a file system. So a NAS file system takes over a lot of all these headaches. I already have a file system. The only thing I need to figure out how to navigate in the file system, how to create a file, how to open a file, append information into the file, and then saving back and stuff like that. It's much easier to operate in NAS than SAN if I'm an application developer. But basically, object is the easiest way to developers to work with. So developers know the HTTP protocol already, and there are only 2 commands they need to learn. One of them is get, if they need to access an object from the file system, and the other command is put, and that's it. Get, put, so that's extremely easy to handle. So basically, if I'm a developer, I create an application which generates a lot of data or accepts clients a lot of data, then the only thing I need to do, I authenticate myself in the object store. If I need to store something, I put the object. If I need to get something, I just download the object and that's it, put get. So in object store, there's not even a command for update. So there is no update block. If I'm updating the block, I look at the information, I change the information I want to change, and then I put it. And there's basically a new version of the same object. Okay, any question till now? So do you have a roughly understanding how an object store would handle? Okay, let's go forward then. Sorry?
DE?
Sorry?
You don't have DE?
No, so then there will be actually an example at the versions, but there is no delete. Typically, you don't delete from the object store. The main purpose of the object store is to store data forever. Like, let me give you an idea. When we basically build the product, so the storage build is coming from an acquisition. We bought this company, I think in 2009, and the original product was built for healthcare, so for hospitals. It's in the US, the hospital industry is a little bit different. There are a few service providers who do services for hospitals, and they do the IT services. So it's not like here, in Southeast Europe, where every single hospital has its own IT operations. It's much easier. And basically, the original requirement for object store was that you need to store the patient data for the lifetime of the patient plus 20 years. But how you can create what's the lifetime of the patient, so they had to guess something. So they were building the object stores to be able to store data for 120 years, because that's what they guessed, that the kind of maximum lifetime of the patient is 100 years plus 20 years to store the data if they want to do some kind of research. So there's no idea of deleting data from an object store. You may update an object, but you don't delete. All right? So our implementation is basically it's a software. So when we purchased the storage grid appliance, the developer company, it was all software. Obviously, later we added appliance options and things like that, but at the end of the day, it's software. So even customers who are not purchasing hardware from us, they can go ahead, download the trial version of Object Store, and you can work with it. It's a geo-redundant thing, so we can build out an Object Store up to 16 sites, and they replicate data between each other. It's very important that this is meant to be the dead end of the data. So that means that, so for example, if you compare to SAN and NAS, when you build a SAN-based storage, typically the storage arrives with a backup solution. So typically you buy a storage and you already have a backup solution, or you buy a backup solution with it. So there's always a backup attached to a primary storage. This storage is secondary, so there's no backup assigned to it. So this is where you are going to store the last version of the data. So there's no backup on an object store. There's no DR version of an object store. There's no replications between object stores. We use policies. So I already mentioned there's a huge amount of data you are going to store on object store, so you don't handle the data manually by objects. So the objects are typically generated by applications. You are dealing with millions and billions number of objects, so there's no way to handle the objects by itself. From protocols side, we support S3, which is the de facto standard of object stores. We support Swift to be able to work in OpenStack environments, although OpenStack environments now support S3 as well. And we also have a NAS gateway, so you can use NFS and CIFS. Now, I'd like to remember that just because it supports NFS and CIFS, it's not to run an Oracle database on an object store, because the data access type and the way you store data is not really different. The reason we need a NAS gateway in front of the object store is to able to handle old-fashioned applications which would benefit from an object store, but they cannot change the application to be able to work with the API, but they can handle, for example, an NFS shell. And it's a durable, low-cost storage. So low-cost is important. So if you go for a high volume in terms of capacity, low-cost is extremely important. Let me give you one more example of comparing NAS to object storage because it gives a very good idea. So let's say you want to park your car. Okay, if you go to shopping, like I think you have Ocean here, right? So you go to the Ocean, you park your car, and basically that parking works like an NAS. So you go into a specific row, you park your car, and you remember where the car is. So when you go back to collect your car, it's exactly like an NAS. You know the path, the path of the car, and you know that how the car looked like, what color and what was the plate number and stuff like that. Object store is much more like valet parking if you go to an expensive hotel or to the opera or whatever. You drive in, you give the car to someone, you get a ticket, and when you go back, you just have the ticket and you hope that you get back exactly the same car, hopefully in the same location. But you have no idea that how they park it, if they use a garage or the lift system or whatever. The only thing you have is you have a unique identifier. So that's object store. Okay, so a little bit of history. So we started to work with the object store in 2010, and the interesting fact is that so we are a storage company. So we started to see that service providers are starting to show an interest for object store. So as we are a storage company, we went to the Ministry of Storage Companies, that's called SNIA, the Storage Network Industry Association. So we went to them and asked them that, hey, we want to serve object store, so what's the protocol in the cloud? And they said CDMI, that was the Cloud Data Management Interface. So we went back, we implemented CDMI, and we had no customer interest for it. So we were selling CDMI for a year, and nobody was interested to buy CDMI. Meanwhile, Amazon came out with S3, and they implemented S3, and all of a sudden, well, everybody wanted to buy S3. So we had to implement S3. So ever since we have S3, we have actual sales. So generally speaking, today we sell more object stores into enterprises to have core data use cases and service providers rather than the original use case for healthcare. Typically, you talk to a global namespace. So basically, in this example, I have 4 sites in this storage grid implementation, and basically, you ingest the data on the west side, and you can get that exactly object on the other side. So basically, every single site and every single interface goes to the same grid as a single namespace. So in terms of maximums, we handle 16 sites, 120 petabytes of capacity, and 100 billion objects. So that's how we work. We try to implement as many Amazon features in terms of S3. So there are a couple of interesting things in the new S3 implementation. So for example, we do a replication to Amazon S3. So for example, if you have a specific Amazon feature you would like to use, but you don't want to push every single of your data to Amazon, you can select a specific bucket and you can replicate it to Amazon to get the job done. The reason we are doing this because although a lot of customers are saying that we are not going to go to Amazon, for example, there are a lot of features which are much easier to access in Amazon than, for example, to do it on premises. So for example, if you want to do Hadoop, it's much easier to access Hadoop as a service in Amazon or Elasticsearch than build your own in your own data center. The other interesting feature, which is kind of reverse of this, is that sometimes you don't want to even replicate your data into Amazon, but you want still use Amazon services. So what we can do is that you insert one block inside of the storage grid. There's a notification feature in the S3 protocol, so you can run the specific service on that object. And once it's done, you can insert back the information into your on-prem storage grid. So for example, you have a client base and the clients are uploading pictures and you want to run, for example, face recognition on the picture. So you take that single block, you run the Amazon service on that block, and once it's finished, you can insert back the metadata in your on-prem storage grid appliance. It sounds like a little bit like future, but that's where the direction is going. So as I said, object store is meant to be a reliable place where this is your last bastard where you store the last piece of data. So what we are going for is availability and durability. So we want to make sure that we have different levels and different layers of security which can make sure that the data is safely stored. So what we do is we use layered. In object store, we call it erasure coding. So erasure coding is similar to a RAID, so it's a data protection technology, but erasure coding can work between different nodes in the storage. So the way we handle physical security, we use two-layered security. Inside the storage system, we work between the drives to make sure that we can handle drive failures. So if you use our E-series technology, on the node level we are using DDP. And then between the nodes we are using erasure coding. So for example, if I build a 3-node storage grid appliance, then between the nodes I have replication. So if one of the nodes is falling out, I still have the other two to serve the data. Inside the appliances, I'm using DDP to be able to recover after a drive failure. We have 3 types of deployment options. So as I said, generally speaking, it's a software. So we sell it as a software-only option. The software-only option can be a VMware appliance. So you download the VMware appliance from our support portal. You take basically 3 of them, and you can go and serve your portal. We use bare metal servers. So if you don't have VMware or if you don't want to use VMware to store or serve object store, you can just take nearly any server and install nearly any type of Linux on top of that, and we can deploy object store. You can either go with the commercial version of Linux, so you can go Red Hat, SUSE, or whatever, or you can go with the complete open source one, so we fully support Debian and Ubuntu. And basically the way we deploy is that we use the Docker engine to deploy the storage grid node. And then the last one is the appliance-based model. So obviously we have storage appliances, so we made a special version of the E-series appliance, which can run the storage grid software on top of the physical controllers, and that's how we run.
But what operating system is on this object?
The operating system of the appliance, the software appliance, is Linux. The way we run it, if you take the VMware appliance, that's basically a virtual machine you deploy.
And on the command line, the same commands as in NETAPP?
No, so actually you don't use the command line.
No.
So basically we have an admin node. There will be an example, but basically the way you deploy is that you deploy the admin node first, and the admin node will manage the storage nodes. So for high availability, you need at least 3 storage nodes, but the only management you do is in the GUI. So the Linux is only doing like to run the object store service, nothing else. You don't need to do anything in the CLI or.
And can we encrypt the data with some appliance?
Yes, we do. You can encrypt the data inside the object store as well, or in the appliance-based model, you can go with encrypted drive, so you can do hardware encryption as well. It depends which model you go with.
But we used to have some out-of-the-box safe hack.
Mhm.
We have it not in the location where the storage is.
Oh, okay, so in the appliance-based model, we are using the E-series disk encryption, and the E-series disk encryption is on board. I'm not.
The key is also on board.
And the key is also on board.
But the
Yes.
client wants to have the key outside.
In different locations. So this one I would check with the product management if they have that deep level security for it. Because this example, I've never seen this before. The interesting thing is about object stores that, just give me a moment. So when you build so typically, okay, you start with a single location object store, but to get a reliable object store, you typically go at least 2 or more, like 3 locations. So it's easier to solve physical location security in 3 locations, because even if one of them are compromised and even stolen, the other 2 locations still serving data, and you cannot really build any information about, So if you have 3 sites, that means that you have 9 nodes. Okay, one of them is broken into, one of them is stolen. You cannot really reveal any information out of that 3 nodes. It's similar when you have a RAID set and you steal 2 disks. You cannot reveal the information. Make sense? But I will still ask if we work together with
The
safe
problem is that we
enterprise.
have a requirement from
Okay. I will still ask for this.
On the appliance of the hardware side, do you still make a RAID as in volume?
We do DDP, yes.
Because the volume can work with the SafeNet key manager and encrypt just on the volume basis, not on the disk
In
basis.
E-series, no.
Not anymore. The old ones used.
The E-series is using onboard key management only.
Oh.
So basically the data protection model is that in the appliance we use DDP. In VMware, the VMDK you provide to the appliance is going to be already protected. And on the bare metal one, again, either you use a shared storage which provides data, or what you can do is to have an internal RAID card. And also this gives the idea that, okay, if you have this client requirement, then basically you can use the bare metal or the VMware-based method, and you can combine it with ONTAP, which ONTAP supports the SafeNet devices. So that's possible.
You can also encrypt with from application level.
And you can also, yes, that's also true. So basically you can encrypt the object itself, and then you have in-flight encryption. To give you an idea on the appliance model, we have a couple of versions. We support the 2-unit 12 drive or the 4-unit 60 drive. We work with 4, 8, and 10 terabyte drives. So basically, you can build a fairly big appliance-based model. In a single rack, we can include 3.5 petabytes of object store after data protection. So that's pretty big. From licensing point of view, we have 2 types of licensing. You can buy a license and, typical perpetual license and own it forever, or we have a subscription base, so this is more like the cloud-like consumption. You start to use object store and you just pay as long as you need it, and as long as you require the capacity. We have a demo version of storage grid, so if you want to try it or do proof of concept, you can. I have one on my Dropbox, if I'm not mistaken. It's not unlimited in capacity because it's only 5 terabytes, the maximum what it can handle. But in terms of functions, it's fully functional, so there's no limitation there. Or if you like Amazon, then you can go ahead and we have a proof of concept on our cloud portal, and then you can go ahead. So I have an example how we built our storage grid environment, so that can give you an idea that how you can get started. So we have 3 sites to get absolute high availability site level protection. Thank you. To get site level protection, you need 3 sites. Typically between the 3 sites, the erasure coding what we are using is 6+3. So that means that any 3-node failure can still, you can still have the data available and you can still search data. So if you lose any of the sites, then basically you are good to go. So the first thing we do is we deploy the admin node. So basically, after you install these appliances, you take the admin node has its own appliance. And when you start up the appliance, it has basically a web-based GUI. You do like a next finish. It's typically 15-20 minutes. You can go through and you can install the whole thing. And once the admin node is up and running, you can start to add the storage nodes. So basically, the storage nodes are the ones which are serving the object store. So as I mentioned, the storage nodes can be VMware, Linux, or NETAPP appliance. In the Vancouver side, we only have VMware, so we have VMware appliances, and the VMware appliances are using storage from FAS, from E-Series, and from third-party storage. Obviously, we have a lot of third-party storage. We buy like EMCs and Hitachi's from customers, so we are reusing them to serve object stores. In our Sunnyvale side, we only have Linux. So we run the object store on top of Docker, and all of the servers just use internal storage. So we ordered all of them in internal drives with internal RAID, and we run the object store service on top of Linux. And in RTP, we don't use anything else than NetApp appliances. So basically, we have these 3 sites, complete mixed environment. We have different applications. We have our own built web applications which use S3 as a protocol to store data. So for example, if you use Synergy, if you use the hardware universe, they all take the data from storage grid. If you use our websites, the websites, they store all of these images, all of the information in the object store, and the front ends are serving the data from S3. We have, in a different tenant, we have an OpenStack environment, and for the OpenStack environment, we still use Swift. I heard that Swift is going away from OpenStack, and going forward, OpenStack will just use S3. But as long as Swift is available, we still need to use it to be able to, show it to customers that that's working. For authentication, we are using Active Directory, and in the OpenStack environment, obviously, we are using Keystone. Basically, any type of LDAP compatible authentication will work with objects, with storage grid, so it doesn't have a very specific requirement. So we have a global namespace, as I mentioned. So in one site you insert some data, and that data will become available to any of the sites. So any of the sites will get the global namespace. Now there are 2 things in the object store. One of them is replication. So for example, if you insert the data here and you say that this will be a hot object and I want to use this object on every single of my site, then I create a policy to replicate this object, and this object will be replicated to every single storage node or every single site, and all of them will access locally. The other thing, if the object is not going to be that hot, you can say that, okay, I just want to erasure code it. So I take the object, I take it to 6 pieces, and I distribute it. I generate parity data, so I distribute it into 9 basically storage nodes. What I can mix these. So for example, I can say that I insert this data, and for 2 weeks, maybe for a month, it's going to be accessed by many clients. So for 1 month, I want to replicate it and available from everywhere. And probably after 1 month, nobody will need it. Sometimes they will read it once in a month. So after that, I want just to do erasure coding. So basically expanding object storage as easy to add additional storage nodes. This is how you extend with capacity or with performance. Obviously for different performance requirements, we can build environments with more storage nodes and less capacity. If the requirement is more like performance on the object per second terms, or we can use more drives and less controllers if the performance requirement is more like a throughput-based requirement, for example, for backup applications. Expanding is with additional storage nodes. We have archive nodes, and basically the archive nodes can use tape. So if you want to use or you need to use tape still, you can attach tape to the object store, and then the tape part will be part of the global namespace. So you can define policies that, okay, after 1 year I need to store that object only on the tape, and then when you want to read it back, you still use it as an object. You get on the get operations, and basically the storage will read it back from tape and serve it to the clients. And you can also tier it into cloud, so we can replicate into Amazon. You can use Amazon as an extension of your own object store service, and you can define policies that, okay, I want to create 1 copy on-prem, 1 copy on Amazon, or after, I don't know, 1 year, I just want to keep it in the cloud.
Can you delete some data?
You can. So you can delete. So there's. I think that's the next one. Yes, there's versioning. So in S3, inside the protocol, thank you, there's versioning. So basically you insert data, and after inserting the data, you can insert what we call a delete mark. And the delete mark will tell the object store that everything before this is now there. So the thing is that when you create policies, you can create policies to store the data forever. That's the default, because that's the default use case. Nobody is brave enough to delete data. Or when you create a policy and when you say that, okay, this data for sure I will not need after 10 years, in the policy you can define that, okay, for 1 month I want to replicate an availability everywhere. After 1 month, for 10 years, I want to just erasure coding. I need to store it. I need to make sure it's stored. And after 10 years, when 10 years mark in, I want to get rid of that object and delete it. Thank you. So that's how it works. Okay. So basically, this is the big picture. The last feature is, as I mentioned, we have NAS gateway. So if you have like legacy applications which would benefit from object store, but they don't have the API, or you cannot rewrite them, or something like that, you can attach a NAS gateway in front of it. So the NAS gateway will just provide a NAS interface to the object store. So every single incoming data which comes in a NAS, it will be basically just translate to object and store the data. And the interesting thing is that whatever you insert on the NAS interface, thank you, then basically you can access that as an object on a different site. So you can mix and match NAS with objects.
Which version of the software do you have to use to get the NAS?
You always want to use the latest version. I think the NAS bridge came in 10 something. Now we are 11.1.
I mean the hardware appliance.
It doesn't matter. So the features are all over. So every single feature I described, it doesn't matter if they are great features. That what kind of appliance you use, it doesn't really matter. So that's it. This is what I wanted to tell you about object stores and storage grid. There's a couple of icons and a couple of companies we are working with. Typically these are backup applications and analytic softwares and stuff like that. But basically everything which understands S3 is good to go in a storage environment. Right? So thanks so much. That's it. So basically this is an on-prem version of the Amazon S3. obviously with its benefits and pros and cons. So thanks a lot for coming for this extremely late session. Doru has some special gift for everyone that you came for the dinner session. I said that dinner is not included, but at least thanks for staying with us till like 6 p.m. Thank you, and hopefully see you next year.